In this section, we're going to look at integrals involving trigonometric functions. And for a large number of these, we can use substitution. In this case, for example, if we have the integral of sine to the mx times cosine to the nx dx, no matter what the m is, if the power of cosine is odd, then we can always use the substitution u equals sine of x to solve this integral. And of course, if we make that substitution, du is cosine of x dx, and we can split off that single cosine for du, and the remaining powers of cosine are even, and we can convert cosine squared to 1 minus sine squared. This will work even if the m is 0. Let's look at an example. So suppose we want to integrate sine to the 5x times cosine cubed x dx. So the claim is that here, because 3 is odd, we can make the substitution u equals sine x. If we do that, then du is cosine x dx, and we can convert cosine squared to 1 minus sine squared, which is 1 minus u squared. The integral that we're looking at, the integral of sine to the 5x times cosine cubed x dx, is equal to the integral of sine to the 5x times cosine squared x times cosine x dx. And du will replace cosine x dx, and we can convert the cosine squared to 1 minus sine squared, which will become 1 minus u squared. So when we've done that, our new integral is the integral of u to the 5 times 1 minus u squared du. And this is pretty simple to calculate. Just using a power rule, we split it up into the integral of u to the 5 minus the integral of u to the 7, and we get u to the 6 over 6 minus u to the 8 over 8 plus a constant. And then replacing the u by sine of x, we get our answer is sine to the 6x over 6 minus sine to the 8x over 8 plus a constant. Now this substitution even works if the sine function doesn't appear in the integral. If we have an odd power of cosine, we can also make this substitution u equals sine of x. Let's see how that works with the integral of cosine to the 5x dx. This is cosine to the 4x times cosine x. When we integrate, that's equal to the integral of cosine squared x squared times cosine x dx, which is the integral of 1 minus sine squared x squared times cosine x dx. Now we can make our substitution, that u equals sine x, then du is cosine x dx. And because we've written everything in terms of sine of x, or du, we have our integral of cosine to the 5x is the integral of 1 minus u squared squared du. And that's the integral of 1 minus 2u squared plus u to the 4 du. And we can use the power rule for that. That's u minus 2 times u cubed over 3 plus u to the 5 over 5 plus a constant. And now replacing the u by sine x, we get that our answer is sine of x minus 2 times sine cubed x over 3 plus sine to the 5x over 5 plus a constant.